A very good morning, everyone. Thanks for joining us for this insightful webinar, Accelerating eVTOL Development with Ansys Multiphysics and STK Mission Engineering. Today, we have with us Mr. Shashikant, who is the National Technical Manager of Softcell Technologies, as our speaker. A brief introduction of Mr. Shashikant. He's a seasoned multiphysics simulation expert with over 12 years of experience. He's certified by OEMs in CAD, 3D modeling, FEA, and CFD. Today, Mr. Shashikant will take you through how leading aerospace and advanced air mobility innovators are leveraging Ansys solutions to optimize vehicle performance, reduce physical prototyping, and validate operational missions before their first flight. Over to you, Mr. Shashikant.
Thank you so much, Tanvi. Let's begin with webinar. So my name is Shashikant, and as Tanvi told you, and I am a National Technical Manager and having more than 12 years experience. About my academic experience, I did bachelor's in mechanical, master's in design, and PhD in material science. Currently, I am doing master's in AI ML for the automation from Liverpool University through IIIT Bangalore. And we are from Softcell company. Softcell is a very reputed company in the India, and we are available in multiple locations, and we are having good amount of customer existence with us. And today we are here to showcase you how Ansys can help you to develop eVTOL very smooth way, and how you can make quality improvement in your eVTOL. So we have a multiple solutions which can give you solution from beginning to delivery of the eVTOL. So, and very important thing, we are the channel partner of Ansys company, and Ansys is now part of Synopsys. So let first understand about the agenda, what we will do today and what we will present today. So first I will just give you introduction about Softcell, then we will showcase you how Ansys can help for the eVTOL development, and what is the important of simulations and aerodynamic simulation, how it can help for the development of eVTOL. And we have a multiple type of physics like structural, electrical, thermal, and we have also mission analysis possibility in the Ansys solutions. We have a multiple solutions which can really help you to do simulation virtually in Ansys platform. So let go for next about the Softcell. So Softcell, as I told you, Softcell is a very reputed company in the India, and currently we are having more than 750-person team available with us, and we are available in 6 offices in Pan India, and our last year revenue was 1024 CR. And our team is having more than 30 years experience, the higher management. And we are available in market for the PTC solutions. We have partnered with PTC. We are having partnership with the Ansys, Sigmatrix, and Microsoft HoloLens. PTC for 3D modeling, Ansys for simulation, Microsoft HoloLens for IT solutions, and Sigmatrix for the tolerance analysis. It may be 1D and 3D analysis. We have a multiple option with the Sigmatrix. So today our target is present you about Ansys solutions. If you look into, if you want to see any other solution like Sigmatrix and etc., you can connect with the Tanvi. So these all are the location where we are available in a good strength. So before going about the deep dive in the solutions for the eVTOL, I will give you intro about Ansys solutions. So Ansys solution is having big amount of physics available there, which can be operate in single interface. And our initial product was Fluent, and currently we are having Granta for the material property library. We have optics for optics simulation. We have LS-DYNA for impact test, drop test, crash test, and ZMAX for lens simulation, visibility simulations. We have a multiple type of solutions. So and these all our solutions are expert in their field. Okay, they already have a good amount of experience in their domain. So once if someone want to utilize these solutions, so there's no any hurdle or any problems in the terms of the virtual simulation. So like why this digital engineering is required? So mainly technology is advancing rapidly, and systems are increasing in complexity, and demand for innovation and time to market is required, and drive operational efficiency and reduce the cost. So normally what we do, we do 3D modeling, we do 2D modeling, then we will go for the manufacturing. We will develop eVTOL. Once we develop eVTOL, then we will have a multiple intent trials in real world. So once you are doing attempt trial in real world, and it will take it will take a long time for the testing also, and you need to do minimal 10 to 15 iterations to get required design or a safe structure of the eVTOL, or like efficient eVTOL. So what we do, what I say normally, whatever you are doing 10 to 15 iterations, don't do direct these physically. Do at least 9 to 10 iterations in virtual simulation. And in virtual, what you have a benefit, you can do multiple iterant trials in a fast forward way, and you can see failure mechanism of the product virtually very easily. It may be structural, it may be aerodynamic, it may be electronics, it may be acoustic, it may be mission analysis. So you will do all these things easily in virtually. So honestly, if you do this thing or virtually, you will get tracking about your product very easily. Then you can develop or modify as per the failures virtual condition. Once you get satisfied with the virtual results, then go for the physical testing, like validation 1 or 2 times only. So if you see, initially you're doing 10 to 15 iterations, it is taking a lot of time, a lot of money. So while you're doing virtually, it can be done very fast and within very less cost. Also, physical model, it required huge of money. Now, this is something, as per my experience, if someone want to develop eVTOL, so these normal questions they have in their mind. Okay, so this is something initial stage. So, like first, system users definition, where this system need to be used. And second, we need to see system architecture about mission and ops and vehicle integration, payload and structural avionics and flight controls and thermal and software and communication and safety and reliability, manufacturing support. These all architecture we need to understand. Then first you got to understand, we need to do preliminary simulation to see the path of the eVTOL. Let's suppose you want to run this eVTOL in Bangalore area, or maybe in Gurgaon city, in Mumbai city. So you want to see eVTOL when it will fly. So and then we will have any restriction or how much battery is required to reach the destination. If the battery is getting earlier discharge, or something, a problem in the communication with the station. So like if you want, like we want to do preliminary simulation to understand something, the output, it is good or something normal. Once you've done this thing, then we need to see about the component based simulation. So we need to do deep dive simulation in the terms of the optics visibility. Let's suppose we have raining is happening and we have a fog in the atmosphere. So because of the fog and because of the raining, how much visibility will be affect? That way we want to simulate. So we have Ansys optic solutions. Using this, you can do. And because of the vibrations and all these things, you want to see structure integrity, how the structure is behaving. We have an Ansys structure. And for the aerodynamic, aeroacoustic, and aerodynamic responses, we have a fluid dynamics. So similarly, we have a multiple solution which can cover all types of the simulation required for the eVTOL. Normally, what we are doing structure separately, we are doing fluid separately, we are doing mission analysis separately, we are doing maintenance separately. So if you do separately, then it cannot be it cannot be accurate results. Just I will give you example. When about water is flowing in the plastic pipe. Okay, so once the pressure is very high, then we can see bulging in on the pipe. Something diameter is getting increased. So the pipe structure is a structure, and something we can say a body, a solid body, and inside that we will have a fluid as a CFD dynamics. Okay, so we need to couple together. We can see real behavior of the pipe structure. So here we need to use a multi physics. We will have also FSI, one-way FSI, two-way FSI, so we can integrate multiple physics to replicate a realistic setup as per the real scenario. So the coupling can be happen very easily. Then you can track results as much as required required outcomes. Assimilation means simple. I'm just saying honestly, GIGO. GIGO means garbage in, garbage out. So first thing, you need to replicate your setup and problem as much realistic what are happening in the real, like in atmosphere in the real condition. Then apply boundary condition and all these things as per the real condition. Then you will get you can expect real like accurate results. So now go for the detailed design. As I told you, we can see response, multiple response in takeoff and in landing, and while it is going to fly for long distance. So that all can be captured in the terms of the detailed design. Okay, so multi-domain optimization. It means you developed something eVTOL, but this eVTOL is asking for more battery power. Why? The weight of eVTOL is very high, very heavy. So we need to understand from where we can reduce the weight of the eVTOL. So that type of things we can do also. You can do separate like component wise as a structural optimization, as a aerodynamic optimization, as a thermal optimization. So you can do separate also, but let's suppose you want to do combine, we can do also combine to see response of the multiple physics. Similarly, we have a integration with the system. Let's suppose software and hardware is getting integrated, how they will respond. Is there any lack or is there any problem? And we have some MIL or something certification, DGCA certification. They need to have a report. So we can create some reports that can help you to get a certification and validation as per the audit companies. This is something deep dive. As I explained you, I mentioned here pain points like mission for the mission definition, SOS, mission contents and capability, define reference mission, capture emerging requirement in the terms of the simulation architecture model, concept with SSM and system structure analysis, and we can define work and packaging, WPS, and analysis driven trade study. So there are multiple things we need for the like required eVTOL as per the certification. So a very important thing with Ansys also, we have a AI ML integration also. So let's suppose you are doing one simulation, it is taking maybe 10 to 15 days. So we can integrate AI ML to get simulation as much as earlier, and you can get understanding about your product as much as a fast process or earlier stage. So then you can develop your product very fast forward. So these are the things, as I told you, aerodynamic simulation, we can do structural and composite, we can do acoustic. So acoustic, we have a normally, we can say aeroacoustic, vibroacoustic, and hydroacoustic. So these all can be captured, and controls and autonomy and energy and thermal management for the electrical simulation, screen integrity, power integrity, and crashworthiness analysis and system reliability. So these all can be captured in a smooth way using these solutions. So these are major highlights. So from the beginning, material to delivery of the eVTOL. So as I told you, the input and boundary condition is much very important for the simulation. So for the material data, let's suppose you are using carbon fiber, you have a multiple stack up, multiple ply for the composite development. You are using compression molding a process for the composite material, and as I did some work in the PhD for Bharat Sarkar, so I developed some carbon fiber using I developed some composite using carbon fiber and Kevlar, Spectra, glass fiber was there, and as a composite, we did a using epoxy curing process. So we did multiple types of testing samples, and at the end of the development, we also first there we can say CNT made something a volume fraction of the CNT. CNT is 100 times stronger than the steel, so it can also increase the strength of the structure as much as higher, and weight is really very less. So we want to develop which eVTOL can give a more efficiency in the terms of the flying time. So that can be controlled only using the optimization, and also we need to have a proper safety margin so that we can utilize composite material. So we have a Ansys ACP, Ansys composite pre-post. So these composite module can help you to develop composite material, and you can define number of layer. You can even you can define orientation of the fiber. You can define resin material. You want to see, if you want to see curing process. Let's suppose you are putting for the curing inside the oven. So how much time is required for the curing, or you want to see final component compensation. So in the terms of the composite material compress molding, when we are defining the mold, so once at the end of the final the product will have some shrinkage, some problems. So we need to see compensation is happening, or how we can control this. So these all things can be captured using ANSYS ACP. And after that, you want to do structural analysis, you can couple very easily. So here you can see the PCB can be simulated, battery can be simulated, motor also can be simulated, and complete architecture can be simulated using the Medini. So Medini can give you very smooth way for this highly security of the eVTOL. Same thing as I told you. These all can be captured very easily. And one thing I forgot to mention there: occupant comfort HVAC. So HVAC means someone is sitting inside the eVTOL. So the temperature is maintaining properly, or air circulation is happening properly as per the standard. We want to capture. So that also can be done using our solutions. So you can define vent locations of the HVAC, and you can see response of the vent on a specific CFM. The response is coming properly or not. Otherwise, the vent is required more, or we need to do something multiple iterative trials. So normally, if you do using any simulation tool, you will have a manual process. You do maybe one iteration, second iteration using manual process. We have a very smooth and a very impactful optimization process. One is called as a manual, whatever currently persons are and industry are using as a basic level. We have a second as a we can say a parametric optimization. Third is a topology. Parametric means you can define multiple locations of the vent and using Python code, or you want to do maybe 5 to 10, you can do manually also. Let's suppose you want to create 100 iterations of the location for the vent, you can do using Python code. Once you've done these all these iterations, you just put on the solve. This software will solve complete simulation, and it can give you the results at the end of the outcomes in 100 iteration. Which iteration is good as per the requirement, which is more efficient in the terms of the electricity consumption, in the terms of the strength analysis. So these all things can be done using very smooth way that called as a parametric optimization. You can at least You can also integrate with the outcomes also. Let's suppose you are saying you want to get some specific airflow at the corner of the cabin. Let's suppose you have a corner there, very big problem to get air circulation properly. So you can define a probe point for that location. Once you get defined, you can give a limit like this. Velocity I need at this location. So the system can tell you exact CFM required for the HVAC system, or for the making proper cooling of the or air circulation inside the cabin. It can also recommend you location of the vent. Propulsion also we can do, and we have also in the terms of the radar cross section, and all other I think I capture already. Let's go for next. So this is for the simulation in action for control and sensors, dynamic and word integration. So I will tell you the easy way. We have a STK. In STK, what you can do, you can import complete city geometry, like building and all the small building, big buildings are available in the terms of the block. So once you get import in the Ansys solution inside the STK, then you can run your eVTOL in a real world, like a real world. You can see using multiple paths. Let's suppose I want to reach from A path to B path. We can say A to B location using multiple paths. Okay, so this system can simulate and tell you the response of the battery consumption, and how much time is required to reach B location using multiple path. Okay, so you can decide which path is more efficient in the terms of the battery consumption, and in the terms of the NVH also. So we can do these all things very easily, and just you need to have your model inside the STK, and you need to define the calibration with the SCAD and Medini also. And if you want to see real picture, how we can see from the eVTOL in the ground, it is the landing station is visible properly or not. So that also you can capture using virtual simulation inside the Ansys. We have a AV accelerate the features with us, which can help you to see the real image of the ground, whatever the landing station is visible properly or not. Sometimes we have a foggy area. Fog is very high dense and all these things, so we can understand also once we have a fog density like this one, so we will have a visibility effects. While then now this is some case study for your more understanding. As I told you, aeroacoustic simulation. So once this eVTOL is getting fly, so what we can do, we need to understand about the NVH. So in the terms of the NVH, we have some restriction from DGCA and from some requirement in the terms of the noise also. So what we can do, we can replicate similar boundary condition, similar condition in the virtual simulation, and we can understand while the eVTOL will be fly, then how much noise will be there. There will be 50 dB noise, or 20 dB noise, 30 dB noise, or maybe higher noise, 120 dB. So to reduce this noise as per the criteria, which type of implementation is required. So you can apply multiple implementation in the eVTOL. Then you can do multiple iterate trials very easily and virtually. But honestly, in the physical process, it need a use of money, use of time. Now, one beautiful feature of this software also, before presenting this slide, let's suppose you want to understand about dB, the noise inside the cabin. You can see dB in the terms of the text, but you will say, no, hey Sasikant, I want to listen in a real word. I want to listen in speaker. I want to listen in the mobile. So what you can do, you can couple this all solutions with the Ansys sound. So in Ansys sound, you can listen real noise, how this noise will be there. It will be panic noise, it will be concerted noise, which type of noise there. So the beauty of this software also, you can capture the you can listen the noise in real world also without running your eVTOL in real or physically. You just run your eVTOL in virtual simulation. You can see, you can listen your the noise or the noise of the eVTOL in a real world. So this is one more example. As I told you about the manual optimization and parametric optimization. This is a, we can say, topology optimization. Topology means you see the initial stage of the structure or body of the eVTOL. Just for example, first you can see something circular things are there. So this looks very heavy. So once you get import in the Ansys software, then Ansys can tell you exact as per the loading location, as per the boundary location, which type of structure is required for the eVTOL. This will optimize automatically. It may be a 30% optimization, it may be 20% optimization. It do as per the loading condition, boundary condition. And let's suppose you want to see stiffener inside the braces inside the structure in the cabin. Also, it can generate automatically. But maybe you have a question, hey Shashikant, once the optimization is done in the Ansys software, I want to do manufacturing of the model. So how we can do manufacturing of the model? What we can do, whatever optimization is done in the Ansys software. Uh, but whatever optimization done in the Ansys software, whatever design you have, so what you can do, you can just export this file as a STL, and STL file can be import in any CAD modeling software. It may be SolidWorks, it may be Creo, it may be CATIA. You can import, you can create a manufacturing drawing. It give you something design of the optimized design of the eVTOL or structure, whatever you have. But honestly, if you do physically, it will take a big time, and you will do, maybe you can do maybe 10 iterations within a 2 month, but it will give you final design within a 1 day or 2 days. Now Ansys electronics. So we have so many challenges in the terms of the antenna and SI and power integrity. Multiple challenges are there. Let's suppose sometime we have a cloud or we have a fog, very dense fog. So because of that, and the communication is getting break. So we need to develop something which will have a good place for the proper communication of the IC. So what we can do, you can do it in trials using virtual simulation. You can identify a location of the antenna, but in physically you do you will placing antenna at different location. It will take a long time. So it can give you finalized results very easily. The location for the GPS, location for the IFF upper, location for the IFF lower. So these all location can be defined very easily. Or let's suppose you want to understand about the radar cross section, that also you can capture using virtual simulation. So radar cross section, lightning stack, large scale platform integration, antenna array, RF antenna component, and SIPI EMI simulation, core site and RF interface. So these all things can be captured. So as a something summary, we captured about the structural things, we captured about the aerodynamic things, we captured about the acoustic, we captured about the electronics. And honestly, these all can be coupled easily. So then you can replicate realistic scenario as much as accurate. This is one example for the eVTOL simulation in the terms of the path definition. In the terms of the, you will have a multiple high-rise building in near about the landing and reaching location. So you can identify which path will be more efficient. And one more thing, you can also integrate the airflow. So we will have a something scenario or trend of the airflow in the city with respect to the time. In June, something different type of the airflow is happening. The flow direction is something different. So you can also integrate the AI/ML, or you can integrate the multiple iterations in the terms of the airflow, and you can identify in the terms of the January when we have a airflow, and the terms of the June when we will have a different type of airflow. So how much battery consumption is will be decrease or increase? Which type of problems can we occur? So you can decide the path, or something we can say flying path, different as per the time domain, also maybe as per the month also. Or you can also identify in this month the flying time will be this one, in this month the flying time will be this month. So honestly, this looks like a complete solution uh, which can convert your imagination in real world. It will help you to really. So as I told you, this is example. We have a different type. Wait 1 second. So here you can see different type of the path we considered, and we can see the efficiency of the eVTOL. So you can see in the first path, stable path, but highest energy consumption from air drag, and path B, low energy consumption but unstable with the large turbulence. And third one, you can will see path C, midway between A and B, and large change of air drag forces. So uh, the thing is required money in CRs, crores, to see this response in physically. Okay, but honestly, if you're doing this way, you can do very easily. You can understand. So the conclusion will be the path C, very easily we can understand. Give me 1 second, please. Okay. So in left side images, you can see the high-rise building that can be captured very easily in the STK. We can import complete city, and we can see all buildings are available in real world. That also comes in the STK. So this case is study done with the path flight of 1100 meter from point A to B, and the speed of drone is assumed as a constant 20 meter per second. So now the motor response is must required for this application. Sometime we are purchasing motors from the other vendors. Let's suppose you will say, no, I want to create as per my requirement. So this software can help you also. We have a motor CAD where you will have a template. You can just drag and drop. You can create primary coil, secondary coil. You can create multiple components very easily, and you can simulate when this motor will run on a specific speed. So which type of losses will happen, and how this will give you response. And you want to understand about the temperature generation, noise generation, also NVH, that also can be captured. Maybe the motor is getting very hot, so we need to put some coolant process or coolant mechanism to make it cool. So that also can be done very fast. So for a specific motor development, we have an Ansys motor and all other also Ansys solutions which can help you to develop a motor from a very beginning stage. And here you can see Ansys OptiSlang. As Ansys OptiSlang can be coupled with all solutions of the Ansys. Just I will give you very easy and simple answer. Let's suppose you did 1,000 of iterations using a model or AI model, and you want to understand about the response of the 1,000 iterations. So once you get couple, this OptiSlang can give you the response in the terms of the efficiency, in the terms of the whatever you define, in the terms of the flight time. It can give you the sensitivity analysis. It can give you the response of the product or simulation as per the requirement. Let's suppose you will do using Excel. It need maybe 6 months or 8 months using Excel. You have 1,000 iteration, you have a multiple data there, but it will not be easy using Ansys. It will be, as per me, it will be impossible. So what you can do? just drag and drop OptiSlang with the solution, you will get a response very fast about the like result requirement or optimization process. Okay, so a battery is a big challenge for the industries. Okay, and once we are importing cells and sometime battery pack, I have seen in the market. Let's suppose you are importing just for example 1,000 cells of the battery. I have seen sometime in 1,100 cells is having something different response. Other 100 is having something different response. So while you do physical like virtual testing using Ansys, you will have some standard model inside the Ansys. But let's suppose you want to capture realistic scenario. So we have a reduced order model. That it means you can couple some cells property available responses. On behalf of that, you can capture the realistic scenario. So battery is a heart of the, we can say, the heart of the eVTOL, which is very important. If battery management is happening properly, and then you will get a fast response of the like fast response of the complete multiple physics, or you can increase the flight time of the eVTOL. So in the terms of the once the battery module is getting high heated, we have a multiple type of process to cooling. Normally it called as a forced convection. Second is a natural convection. We can say first natural convection, second is a forced convection. So in forced convection, we can apply some cold plate and thermal plate, which can dissipate heat of the battery in the atmosphere, or maybe out of the battery. So and then let's suppose you want to apply some fan, you want to do force convection using of the different type of the iterations. That also can be happen or possible using Ansys solutions. This is the aging simulation, battery aging simulation, life cycle of the battery. So you can understand one specific type of the input and uses how much life cycle of the battery will be there. And this is a wideband channel modeling UAV to base station. So we want to understand here about the channels, how the response is coming from the station, to track the position of eVTOL, the frequency or power delay, and what is happening there. Power gain is happening in the terms of the JV. So these all things can be captured in the terms of the virtual simulation. So as you can see in left side, we will have a multiple installation antenna flying at the 100-meter above terrain, and we have a 32T or 32B R base station model mounted on the buildings. So these multiple station you will see there, you can define there also. So for the MIL and SIL and HIL, these all are the validation criteria. So we first you can see about the battery also, and second about the range dropper map, and third about the we can say in the terms of the communication of the station and eVTOL, and the fourth about the noise NBH, and the path simulation also using an STK. So these all will help you really for these all certification. And in the very earliest stage, I explained about the optimization in the terms of the structure. But here you can see we can also couple all together. Let's suppose you want to optimize with the motor design, you want to optimize with the structural things, you want to optimize with the aerodynamics. So you can all couple, you can do a final integration for the optimizer also. This is a very beautiful things you can see here about the sensor model, fog condition injected to sensor simulation. So on different fog density. You will see there 150. First one is 150 visibility is there for the eVTOL. Once density is getting high for increases for the fog, so 100-meter visibility is happening. And for next level of the fog density, 75-meter visibility is happening. And in the terms of the higher fog density, you will see 50-meter visibility is happening there. So honestly, in the terms of the real like results, you need to sit in the eVTOL, then you need to see the responses. But here you will see the response using a solution. So as I did with work with the multiple industries, eVTOL industries, so I have seen these type of trends. So original cost was there. You can see the yellow in horizontal. You will see the cost required. The reduced cost is happening. How much? So approximately before the using the virtual simulation, they are investing so much time and so much money. Once they acquired the Ansys solutions or collaboration with the soft cell and Ansys, we are helping them to implementing the simulation virtually, and they are reducing cost till 30 and 40%. It is also depend upon your action time, action or efforts also, but we are always there to support for the methodology, which methodology for the simulation is best to predict as much as realistic results or as much as accurate results. So to summarize whatever I explained here, we will do this later. I will show you some methodology in the Ansys software, how it can be simulated, or how the interface looks of Ansys solutions. So this is the Ansys workbench, and if someone are there from they use maybe 20 or 30 years back. So we have a APDL, Ansys parametric design language. So APDL generally like it called as a classical Ansys. In that you will need to follow the specific steps and specific codes, so which will help you to develop the model or simulation. It look like something a very classical version. Let's suppose you want to create something specific geometry, so we have these type of option. Or let's suppose you want to create something specific type of the just 1 second, let me give you something. You will see the block is generated. Okay, so we have this classical version there, but it is very classical. But currently in the market, Ansys workbench is there, which is very easy and very fast forward, very user friendly to learning to execute the project. So currently the new generation is using this software very efficiently. Why? Let me show you why. In APDL you have seen the process is where it look like something very lengthy, or it is not user friendly. It is like classical. So DRDO scientists or old scientists or old engineers, they have a good efficiency on this, but new generation always try to see which solution can do, it can help us to understand the process for this solution very fast. So let I will show you. This is Ansys workbench. This is the latest things which is very user friendly and very fast forward. So let's suppose I want to import any geometry. So what do? We have this bottom as a component, and at top this is a complete template. As I told you, multiphysics, so we can couple together. So here we will see we have a fluid, we have a harmonic, we have a LS Dyna, we have a encode, we have a SPOS, we have a optimization, we have a transient thermal simulation. So all are there. I will start with the something static structure analysis. So what I will do, I will just click 2 times on this. And the beauty of this interface is this: here you can do multiple simulation in a single physics, single window, or you can also couple multiple physics here. Okay, so in the terms of the structure, when you open this engineering data, you will have a complete material here, the properties. You will have an elastic property, you will have a hyperelastic property, you will have a plasticity, you will have a creep properties are there. So normally Ansys use a standard material as a structural steel, but let's suppose you want to utilize library. So we have a library here also. Once you go inside this, you will see complete library is there. So Granta library is there. You will see the material also there available, and also mention the code and standard from where this property is taken. And let's suppose you will say, hey Sasi, I don't want to utilize this property, I want to create my customized. So you can just give a name for customize. You can define which property you want to give there, this one or this one. You just click there, and you can define the specific value as customized. Okay, so I will give here 7850, and let's suppose material Young's model is 210. Let's suppose I have a position 0.3. You can see the material is done. Okay, so manual or library, you can do both. And we have also library creation. Let's suppose your team is starting with project, they have a 100 material data, so that also you can create here. And in terms of the .xml format, you can save for the future reference also. So in future reference, there's no need to recreate the property, just import .xml file, and you can use as a fast forward. In the geometry, as I told you, we have a option for the importing, and for the importing, we can import multiple type of file format. CATIA can be import, Creo can be import, SolidWorks can be import, SketchUp can be import, Rhino can be import. So the beauty of this thing, native file format can be import also. Native file format means, let's suppose you are making a model in SolidWorks, maybe eVTOL.prt, SLDPRT. So SLDPRT is a native file format for the SolidWorks that can only read by the SolidWorks. Any other software cannot read. So here, what you can do, you can, the Ansys space claim or discovery can read this file very easily. So, and let's suppose you have an unparametric file format, STF, IGS, or Parasolid, that also can be imported very easily. Okay. So once you get import, so you can see the eVTOL like this. You can import completely. You will see the gimbal camera. The camera is there also. Landing legs are there. You will see the motors and the airfoils, and these all things are there. A glass is there, and you will see the complete cabinet for the battery and all these things you can see here. This is a complete panel for the electronics. You will see multiple components are there. Battery cooling process also there. You can see the how it is happening. So this is a complete assembly. Let me show you cross section, then you will understand about the wait one second, the component inside this. Let me go there. You can see the electronics complete system. You can see the cooling also. We applied something different cooling for the electronic cooling process. And this is a gimbal camera, and this is also a system for the antenna. So these all things are available there. Battery system also there. So you can import complete geometry, and you can simulate also. Next, I have also one more reference for you. Let do some simulation to understand about the methodology also. Okay. So what I did here is simply I just imported a main body. You can see the main body is here for the eVTOL, and I created an enclosure surrounding the eVTOL as a air, and I defined the flow of direction, flying direction of the eVTOL here. Once you get there, then let me close this. Then we can do very efficiently. This here, okay, yeah. This important for the meshing. I will do meshing very fast. So we have a geometry tight meshing. This meshing can help you to do meshing very fast. It meshing also very lightweight, which can be solved very fast. So here you can import big geometry which have a more than 1,000 or 2,000 components. Huge components can be there. The meshing can be done very fast forward using this process. You can finalize. You can see also the less mesh quality area where we are getting the quality problems inside the meshing. And let's suppose you want to improve, so we have some automation for the improve the quality. So let's do 1 second. It is not taking time. So let do one thing. What I can do, I can just go there and recheck once again. So this is geometry here. Let me do one thing. Let me just cut this geometry inside this and paste outside this here. Then see the response now, how the response is happening. So go for the, we will have a shared topology to share the topology with the geometry. So it will do shared topology. Shared topology means the structure we have of the eVTOL, and we have a surrounding air. So there should be a energy transformation is happening in the terms of the multiphysics. Once the higher pressure is generating on the eVTOL because of the aerodynamic shape, then we need to see response of the eVTOL body or metal thickness, whatever we have. Let do make it easy. I will do this thing as a delete. I will use only this one. I will go there. I will just define this thing as a name as a eVTOL. Okay, to check the uh, drag coefficient and other things. Done. I will define this as a inlet. This I am defining this direction of the flying. Then this is outlet. And go. Let me do one thing. It's close. Okay. Once geometry is done, you define all boundary condition, then you will go for the mesh. I did a initially I do reset. I will go once again. I will say generate. I say generate once again this geometry. Once the geometry will generate inside the meshing process, then we will apply some boundary condition in the Ansys fluent setup. We will explain how much flying speed is there of the eVTOL, and fluid density, air properties. Then we will see a turbulence model, whatever we want to use. Then we will put on the solve. Once we put on the solve, then we can see response of the aerodynamic shape, where we are getting higher drag coefficient, or how much drag forces are there. That also we can capture all. And at the behalf of that, we can capture the pressure profile on the body of the eVTOL, and velocity control surrounding the eVTOL also, and also turbulence intensity is happening on the body. So these all can be captured very easily. So on the behalf of this all response, you can see how we can reduce the drag coefficient. You can play with the aerodynamic shape, and you can see responses. In the terms of the coupling with the or integration with the motor impellers, that also you can do. You can just import, you can define the RPM of the impeller, so you can understand the thrust generating because of the impellers, how much it is happening, the flying mechanism is happening properly or not. That all you can do using the coupling of the complete simulations. Okay. So I re-imported this. Just I'm doing meshing. Once the meshing done, it done here. Let me go. No voids. I just want to do this thing. I will let's see inlet. Okay, then done. I don't want to do this one. So we have a two geometry there. I want to utilize only one. I want to keep this as a dead. Update. Then let keep one layer, and this is generate. So I just did a 10 seconds time for the meshing. For the normal simulation, basic simulation, you can do fast forward like this. Once you want to go for the more accuracy, so that then in that case you can also do refinement, all these things. So this inside you will see the eVTOL domain cavity is there. We will have a layers. Okay. Now I want to jump for the CFD fluent case. So just click on this and check sign. So the meshing will be transferred for the fluent boundary setup. So now I want to capture the gravity minus 9.81, and I want to see the response of the gravity. So I consider this. We will have a two type of solver, pressure based and density based. You can do also steady based simulation, time dependent steady simulation, which will be not time dependent, and transient, which will be time dependent. So we will have a multiple models here. Battery models also there, acoustic also there, and heat transfer also there. We will have a multiple fluid domain, fluid domains integration also there. We will have a properties also here. Let's do very fast. Go for inlet. I will define the speed of the flying. If it all 20 meter per second, I will say apply. Then go for the initialize, and I will say initialize. Once it done, go for the run. I will do a run simulation using just 100 iteration. I want to just showcase you some results only. So once you are developing light meshing using a proper standard method, the simulation can be done very fast. You can achieve also good quality of results. So normally we do also mesh independent test. We will have also in the terms of the eVTOL also we have some option for the enclosure dependency test. That also we can perform. Let's see some contours here. I will just go to show you some contours. I will do pressure drop. Okay. You can see pressure drop profile. You will see here pressure is high. You can see the flat face is there. Okay. And let's suppose you want to see velocity contours. You will see the velocity contours. So these things can be done. This is a rough simulation. Just for idea methodology. So as per my experience or I have seen in the multiple industry, the methodology is very important. If you understand methodology, if you understand process for the simulation, you can do very easily the simulation. But in the terms of the accuracy, so we have some more option need to follow to get a higher accuracy of the results. This is a vector based results. You can see the turbulence is happening here, very small. Now this is something as I told you, the methodology only for introduction. Let go back for the slide. Session is almost end. Allow me 2 minutes more. I'm done almost. Okay. So just I'm summarizing about the whatever I explained in this complete scenario, complete the eVTOL scenario. So I just want to tell you using the Ansys solutions, you can start from beginning. You can done simulation till delivery. Okay. So all things, all physics can be captured inside the Ansys solutions. So first we discuss about the aerodynamic efficiency. We have Ansys Fluent. For the high fidelity CFD for rotor wake interaction drag reduction on optimized lift. Okay. And the second, rotor noise and urban noise compliance, and battery thermal runway also we can use. Battery range limitation also we can utilize this, and electric motor heating and losses simulations we can also solve. Power electricity reliability, structure weight optimization, rotor blade fatigue, crash worthiness analysis, and passenger safety. And for certification compliance also we can utilize, and flight control system validation, system integration, and complexity electromagnetic interface, also EMCMI, and urban air traffic simulation, digital twin prediction maintenance, and multi-physics design trade-offs. So these all I explained in complete session. So honestly this really helpful for you. I will just showcase you some video that where you can understand about the eVTOL STK, how the STK is working. Okay. You can see the flight, the eVTOL going up from the landing from the station. It is flying. So this is a complete path we can define for A to B, where we want to fly. And for the top, you can see also battery consumption, also NVH inside the cabin and outside the cabin, how much noise is generating. This is a complete integration with the station and eVTOL. Communication response for the architecture, how it is happening, response is happening for complete flight time is properly or not, is there any loophole or something disconnection is happening. So that also we can capture. If some disconnection is happening, so we need to play with the some communication device, or the implementation, or some we can say the iteration in the terms of the improvement of the communication. So vehicle, air vehicle, all things can be coupled about the complete system. It may be electronics, it may be antenna, whatever is there. We can couple all together. Then we can see the response of the complete complete eVTOL. We can define also multiple types of the path, and we can see also a response once again. The cabin noise, how the cabin noise is happening, and how much visible area. You can see the blue area is there and red area is there. Red means you can see, and then the visibility is there. Radar profile also we can see. To ensuring safe journey also, so we can see the certification as per required certification validation is happening out there. Response of the eVTOL is perfect or not. So this is a real image. You can see, you can consider you are sitting inside the eVTOL, how the front visibility is there. Okay, so thanks a lot for wonderful availability. I really help you to, if you have any specific challenges, if you come to us with the specific challenges, we can also plan some customized or customized as per your product, some demos, and we are really love to support you in an extent way. If anyone have a question, they can ask in the text box. I will answer. Yes, Furkan, you can just put text inside the text box. I sent a hi.
Yeah, Furkan, just try unmuting yourself. I've just requested. If it's not possible, you can type it in the chat box.
Yes, we did for you, but some case study are from our existing customers. So I will remove the some case study which is comes in the don't share criteria. I will do customize some slides, and I will we will share with you. Don't worry.
Yeah, our team will reach out to all the attendees, and then if you have any specific requirements, you can again come up with that, and we'll get back to you. Any other queries?
Training, say they send some message. 1 second. Normally, we are believing in the providing training to company. Okay, we can also help you to develop complete methodology for this simulation. Okay, individuals we are not doing. We just trying to implementing our solutions to enabling customer team, like company team members. And once they get enable about the Ansys solution, they will do all solution by themselves also. The benefit of this process. Yeah, Jitendra, you have any question? You can put there. Yes, chemical reactions can be simulated. We have some standard kinetics with us. Okay, that also we can simulate. Let's suppose, sorry, yeah, suppose you want to do something specific or customize reactions. So we have also UDF, user defined function, that also can be integrated. we can do whatever chemical reaction you are asking. We have an Ansys ChemKin, a specific tool for the reactions. Yes, we can also do in the battery thermal management also, right? So after the session, we will connect with you. Don't worry, okay? We'll connect with you for the like customized solution, whatever you're asking, okay? Yes, this also we can do.
Yeah, the propulsion system like test bench propeller with motor
Right,
and propeller
right. We
and
can do.
control and battery. Yeah, so that
Yeah,
all the other attendees also get to know. I'm just reading out the questions. So he's asking if we can test propulsion system like test bench propeller with motor and propeller and controller and battery. All right.
yes. For like honestly, for this physics, we need to for this simulation, we need to couple multiple physics, electronics, and CFD. These BMS also we need to couple, so we can see the response of system-based response, how it is coming.
Any other queries? I think Shashi, we can close the session.
Okay.
Thanks to all the attendees. Thank you, Shashi. Thanks for
Uh,
this insightful session.
Thank you so much, Furkan. Thank you so much. Okay. Thank you so much for wonderful availability. Bye bye. Take care. Sure, we will connect.